Any questions? So just to brush up, we will go through what we had discussed earlier about the structured programming, the style of programming which was very popular in 1970s and 80s. Uh, it's called procedural or functional decomposition or procedural approach, and this all falls under the broad categorization of structured programming. So instead of having your code scattered all over and without any logical structure which is obvious, uh, the structured programming, functional decomposition, or procedural programming is one way of doing that. Makes the intent and what is going on very clear, right? And that makes it easier to maintain the code, that makes it easier to modify the code, update the code, and also debug the code if there are some problems on there. So basic idea of structured programming is the code that you write should never go out of your grasp. You should be able to handle it, you should be able to understand it, you should be able to figure out what is happening where at all times, right? And this requires a little bit of discipline. If you are not very disciplined in your development of code, then it can very quickly grow into something that is absolutely monstrous and very difficult to understand, very difficult to maintain, right? So when I say the functional decomposition or procedural decomposition is one way of doing this, getting into this structured programming. What we look for, I mean, in the beginning, I told you that programming, computer programming is essentially data processing, information transformation. You have one set of information as input, and you want another set of information, desired output, that is the output of the code. And you need to implement this transformation. Now, what procedural programming or functional decomposition aims at doing or implementing is what do you need to do? What are the actions that you need to do in order to arrive at the output, final desired output? For example, we discussed that problem of root finding by using bisection method. Right? There are a set of actions that need to be taken one after the other. First action is find out two values of independent variable which bracket 0. Function evaluation. Function changes sign across those two values. Right? So that is an indication that there is most likely there is going to be a root in between that interval. Right? And then you keep on halving the interval and then again go through the same exercise and work out and keep on zeroing on the interval until you converge on the root of the function to the sufficient accuracy as specified by your tolerance. Now, this is an action that you need to do repeatedly, one after the other. Bracket the interval, root, and then refine the bracket and keep on doing that. So, this is a repeated action that you need to do. Now, we implemented this repetition using for loop or any repetition structure. We did not really go for any special function for root finding algorithm. But we can implement the same strategy as a general function which can be called upon for finding roots of any function wherever required, whenever required, right? And they can it can be then it can implement itself whatever precision you specify. It can be used to compute the roots of any function that you specify. So the bottom line, the emphasis is on the action, what needs to be done, and that is the key word for procedural programming. Every function does something, right? And that information processing that we are talking about is a sequence of such actions, one action after the other, right? So you write one function which does one thing, output of that function goes as the input of next function which does another thing, and so on, right? Until you arrive at the final result, desired output. So that is essentially what I've mentioned here as divide the problem into smaller problems, individual action points, what needs to be done to solve a problem, right? So identify those actions and then single entry and exit points to a function. There are certain inputs and there are certain outputs. Nobody can jump in to in between. It should not be possible. And then to make use of limited control structures, too many complex structures again obscure the logic, flow of logic. I mean, you do not really uh, keep pace with too many logic structures, control structures. And when you segregate into different functional units, then we'll come to this little later that every function has its own memory space. So the space, the variables, the data that you utilize within a function is invisible to other functions. So accidental overwriting is again avoided, which is very much possible if you do not have any function and all the identifiers are available at all subsequent points in the code, which is what you do if you write a single main program which does everything. So the basic idea of functional decomposition is to enforce logical structure in the program. Program is divided into smaller parts and a function is used to solve one subpart. So one set of action. So one function, one action. Design your code in such a way that one function does one job and it does it well. Right? And if you do that, then you will find that the structure and logic of how you are solving the problem becomes very very obvious. You are doing one thing after the other, one thing after the other, and so on. So this logical sequence of actions that becomes very very clear, and that itself tells you about how uh, the particular problem is being solved by different sets of action in particular order, right? Now you can have function definitions and you can have function declaration. uh, you can have function which return values. For example, main is a primary function which returns an integer value, which we use it as a exit code, return code, to indicate whether it was a normal execution or uh, abnormal termination. But main does not take any inputs, or it takes inputs only in the terms of number of arguments that the function online command line arguments it will have during the runtime. But apart from that, main does not take any input. So what is the difference between function declaration and function definition? Look at this piece of code that you have at the side. Right? This, I define a function add. It doesn't do anything. It's a very trivial thing. It just takes two integer arguments x and y. It adds up both of them and returns the sum of these two integers. Right? So it is an integer type function and it takes two integer arguments. So here the complete function definition is given. Right? What this function does, complete implementation of the function is given here. And then the main starts, main driver function starts, and main driver function refers to this add. Now imagine if you did not have this function, this piece of code defined here, this would have caused an error. Compiler would not know what is add ij, right? But because you already had this definition here, compiler knows that add is an integer returning function which takes two integer arguments. So when it is invoked by main with two integer arguments, it knows what it needs to do with these two integer arguments, and then it knows that it has to return an integer output which will go into standard output stream. Let us now consider a case where this function add was provided by some software library. For example, you make use of a square root function, right? Square root function is provided by the maths library, and that is contained, that is part and parcel of the compiler, right? When you install the compiler, C compiler, C++ compiler, the square root function is defined. But if you use square root straight away in your function, in your program, compiler will complain about the function not being known or it not being defined unless you include the math header file. Math header file contains the declaration of the function. What is the square root function is? What is the square root function? What is its return type? What is its argument? What is its input type? So that the compiler knows that this function has this input argument and this output type. It will be taken care of during the process of linking. The function, square root function, if it is called, it will be invoked, it will be compiled from the shared libraries, and it will be, that process will be taken care of during the process of linking at the time of compilation and linking, creation of the executable file. But during the compilation, creation of the object file, it doesn't know, compiler doesn't know, because square root is not a function that you have defined. It is a system function, right? So that information needs to be provided to the compiler that this function, although it is not defined, the complete definition doesn't exist here, but this is a function which takes these arguments, these type of arguments, and its return type is so and so. It may or may not have a proper return type. It may be void function as well. It may be any standard return type function as well. So once this is there, compiler recognizes it, registers it, and then whenever reference to that particular function is encountered in the subsequent process of compilation, that is compared with that declaration whether it matches with that prototype declaration. This is called prototype declaration, function prototype declaration, right? And that is bare essential that you need to have before you can make use of a function. So in prototype declaration, the variable identifier is not really required. For example, I could have written this function as whatever I need to write here. Right? So if I did not have this declaration, compiler would complain about this. Add is not defined, right? But because I have this declaration beforehand, compiler knows that add is a function which takes two integer arguments and it returns an integer return type. Subsequent definition can follow here. I can, right? Pardon? Why did we take R as 0? That's just initialization. R is just an identifier. I could have just said Z as well, but I guess in the example I have been using R, so I continue with R, right? So just nothing special about it. But it is always a good practice whenever you define an identifier, always initialize it to some same values. Do not leave it uninitialized. It may lead to uh, unpleasant surprises during the execution. So this is another, and this function, once I have this declaration here, this function definition could as well be in a different file, it could be in a different library or whatever. As long as for the compiler, all that it needs to know is what is this function add, what is its argument types, what its argument types are, and what is its return type. That is all it needs to compile this sentence, this statement. What it will do During the invocation, that depends on the when the object file of this function is added to object file of this function during the process of linking. Process of linking goes as the compilation process. It goes through preprocessor. C preprocessor where it will implement all the preprocessor directives. I mean macros, define, conditional compilation, etc. All those uh, will be interpreted and suitable code which is ready for compilation would be generated. And all the comments will be stripped off. That is another thing that is done by the preprocessor. All the comment lines, they would be stripped off, they would be replaced by a single white space character. Right? So be liberal, do not be uh, stingy when writing comments in your code. That is not going to compiler anyway. So while you are writing the code, be liberal with the comments. That is for your understanding, and that will be those comments will anyway be stripped off by the C preprocessor. So this would be sent to compiler. Compiler produces object files. This is sent to linker to combine object files and libraries. And from linker, you get the executable code. Yes, you had some query, Himanshi? No, this is declaration. This is prototype declaration. It only speaks, it only tells the compiler that add is a function which takes two integer arguments and it returns an integer type. What it does, there is no details here, right? So that compiler doesn't have, I mean, it is not confused. Compiler doesn't need to worry about when it encounters this line here. Compiler knows exactly, I mean, it only does the it has to do at this point it only has to do the matching whether the arguments are of correct type. When I am calling this add here, am I calling it with integer type arguments? So that is what prototype will be used for, and whether the output type is consistent with the use that I am putting it to. Yes, that goes in definition, that is function definition. So this is what we call as declaration, and this is what we call as definition. Now, if function definition comes before the function is used anywhere, then of course the declaration is redundant because the compiler knows what the function does. But many a times your function may not even be in the same uh, file, same code. It may be somewhere else, right? But in that case, you need to tell compiler for because C is a strict type checking language. It does not admit any mismatch of argument types, right? So if a function requires two integer arguments, it will accept only two integer arguments, if nothing more, nothing less. So if I call add here with two float arguments, it will be flagged as an error, right? Because I have defined the prototype as the function add requires two integer arguments. If I call it with float arguments, that will be an error. Yes. Code will compile for object file creation up to this point. Produce object file for main, right? Subsequently, it will look for when the linker, it goes to linker. Linker will try to find out where is the definition for add. If it does not find a definition of add, then linker will flag an error that add symbol is not defined. Yes, yes, that then it will run. That is what I have done in this example. Here I have defined it, and therefore declaration is redundant. I don't need to declare the prototype here because the complete function definition is there. So declaration is anyway redundant, right? So just to summarize again, functions should be declared first, prototype, if the definition comes after the calling function. Data type of the return value from a function should be explicitly indicated, and if a function is not required to return anything to the calling function, then it should be declared as a void type of function. It does not return anything. Now we can pass arguments to the function. If you do that, just as we have done, what that is a what we call as passing by value. We are passing the value of the function variable identifier, and it can also be the arguments can also be passed by reference instead of by value. The content of the identifier, we can just pass the address of that location, and then that content can be accessed in that location can be accessed, and it can be overwritten as well. If the arguments are passed as values, then of course those contents cannot be changed, right? And this is particularly for C++. This does not happen in C. Overloading functions can be overloaded. For example, what does overloading mean? Any ideas? Just wild guess. For example, I little while back I just mentioned that if I have that declaration int add int, and then if I call add as with two float arguments, that would flag an error. Now I can have different declarations. I can also have float add float, right? Function is same, The arguments are different, the return type is different. So again, I can have different definition accordingly. So the function name is same, its operation is different. So this is multiple personalities. So the function add is being overloaded here. The same function add can be used to work with integer arguments. The same function add can be used to work with float arguments. The same function add can be used to work with double arguments, double type of arguments. Definitions will of course be different. Compiler will pick up correct definition depending on what is the arguments that the function is being called. So you need to provide all the definitions. Integer version, float version, double version, all versions have to be provided. But when you call the function add and you call it using uh, two float arguments, then the compiler will pick up the version which takes float as the arguments. Right? So this is what we call as overloading of functions. So the same function name can be used to work with different data types. The correct version is picked up by the compiler depending on matching of the parameters when you call the function. Which parameter type matches with which definition of the function. And then appropriate function definition is used for creating the executable application during the linking. So not just the type of the arguments, the number of arguments, the arrangement, the sequence in which the different arguments are called. So all that complete pattern of the arguments to a function, they are matched with the prototype declarations, and whichever prototype declarations matches with the calling sequence, that definition will be used for generating the executable code, executable application. Now we come to little technical aspects of function. So far we have been talking about identifiers. I mean, what some information needs to be processed, and in order to process information you need to store information, and you store information in identifiers. Now we have been talking about, we have been using that catchphrase namespace standard. Now there are also hidden namespaces. Hidden namespaces in C++, those are called hidden namespaces. In C, that is called local scope. So identifiers which are defined in a particular function, they are visible only within that function. So for example, in that add function, we defined an identifier R. So that identifier R is not really available anywhere outside the function add. So this is local to add. If I try to access this R from main, R is not defined in main. Compiler will complain that R is not defined, right? So this integer R, this identifier is alive only within this function space. It has its limited life, right? And it dies. I mean, literally, every time the function is invoked, R is created, and when the control returns, R dies down. It is no longer there, right? So that memory, whichever contains the contents of R, that is not assigned with this identifier R anymore after the control is returned. Now that is the default. Now, if I have not confused you enough, I would like to confuse you a little more that I can have behavior modifier by saying, instead of saying integer R, int R is equal to 0, I could either say auto int R is equal to 0. Auto is actually default. Even if you don't use auto, doesn't matter. It does exactly that. It is created, identifier is created when the function is invoked, and when the control is returned from the function, the identifier is killed. But most importantly is this static identifier. All others we will see. Register is just a request. Register is just a request to find and accommodate this in a high speed location. If high speed storage is not available, this request is ignored. That's all. Extern is external to the function identifier. But static is important. Static keyword actually keeps the identifier value alive between various calls of the function. Just little while back, I told you that if I use this integer r will be created every time function add is called, and it will be destroyed once the control is returned back to main. But if I declare this as a static type, then during the first call of function add, it will be created, but it does not die subsequently. It retains and it remembers its value during its previous call. So, for example, if I have this add and I store something here, during the next call, R will remember what it had. That is what static keyword does. Right? Pardon? No, if you cannot use it outside add, its visibility is still within add. R is still not visible outside add. But across different calls of add, if I call add once, R will be created and some value will be stored according to. Subsequent calls to add will already have this identifier R defined, and it will contain the value which it had during the previous call, right? So this becomes very useful in certain circumstances. For example, if I one of the very common uses is calculation of factorial by a recursive function call, right? Function can call itself, and then there, if you make use of this static identifier, then it becomes very easy to implement that code piece of code. You see, so when you define a function, all variables defined in the function are local variables. Those are not visible. So every function has its own namespace, and that is a private namespace of that function. Outside that, it is not known. those names, those identifiers are not visible outside that function, right? And these also include, I mean, not only the identifiers which have been defined within the function body, these also include the arguments that are taken by the function, that are passed on to the function, right? That are defined in the definition. And the attributes of the identifier, there are behavior modification attributes. You can define it as a auto or a normal identifier, or you can request for a very high speed storage if required, if available, by requesting for a register type identifier. Extern is, as the name suggests, it is an external variable. It is defined somewhere else. Mutable, we'll see, we'll see little later. Yeah, you go ahead. Mutable concept we will see when we come to object oriented programming and class definitions. So let's forget about mutable at the moment. Static, I just explained, it remembers the value in the previous invocation of the function. If you wish to remember the what value it had in the previous invocation. And this beyond the storage class, you can have scope, what is the life of that identifier. Now C obviously requires, it's very finicky C language standard. All identifiers have to be defined the first thing in any function. C++ is more permissive. You can define identifier as you go along, right? So you need not define all the identifiers at the beginning. As you need, you may define identifiers. But then the life of the identifiers is of course uh, defined by the matching pair of braces. One opening brace and one closing brace. Whatever identifiers are defined in between these matching pairs, that is the scope of those identifiers. Those identifiers are not available outside those matching pairs, right? And then linkage is again that is where extern identifier actually is used. That allows you uh, to identify the use the identifiers which are spread across different files, and using again namespace different files, you can have different namespaces, and then you can define namespaces to access to identifiers in a different uh, context or different files, you know. So we'll see, I mean, we'll try to work out small problems which will explain these concepts and how these concepts are helpful in writing efficient codes. I mean, all that we are doing here is learn tricks of the trade which allow us to solve any problem. Right? Now, there is no end to it, I mean, the depth in which you can go. But as I said, you can write a working program with just three things: instruction flow, decision structure, and a repetition structure. Everything else is just embellishment and maybe uh, ease of maintenance, right? So we'll continue with this discussion of function definition and follow it up with some examples of functions and these attributes, different uses. in the example problems that I'll be posting very soon. So while working through those problems, you will uh, need to use these concepts that we have been discussing. And when you use these concepts, it will become apparent to you how these concepts help in simplifying the function definitions, implementation, and problem solving as such. If it was not done using function definition, the problem, the code would very quickly start developing into something very ugly piece of code. Right? So I'll stop here.